Good afternoon, everybody. Everyone enjoying the panels that's happened so far? This fireside chat here aims to continue the conversation we started this morning, led by Matthew, on nuclear and how it fits into the AI sphere as well as in Singapore itself. Just a quick introduction. My name is Sebastian. I am an nuclear materials master's student at Imperial College London. And it truly is a privilege to be here moderating this session here with my professor, representing the next generation and how we can engage in not only the nuclear sphere, but also the AI sphere. I want to introduce my professor, Professor Robin Grimes, who not only is an amazing lecturer and has taught me over the last few years, but also is the Steele Chair of Imperial College London of Energy Materials and the former Chief Science Advisor to the Ministry of Defence in the UK. Professor, good morning. Can you hear us?
Good morning. How are you? Can you hear me okay?
Perfect. Thank you for being here with us so early in the morning. Could you first start by providing a quick introduction to who you are and the work that you've covered?
Well, that's very kind indeed. Look, I'm a professor at Imperial College, but I also work, as you just mentioned, with the UK government and have done for a very long time, both as a specialist advisor within the system, Chief Scientific Advisor for Nuclear in the Ministry of Defence, and previous to that, Chief Scientific Advisor to the Foreign Service as well, which gave me a fantastic place to learn about policy as it's really implemented, at least within one government. And actually, Sebastian, I can just actually make a comment related to that. One of the things that's key for people like myself to be cognizant of is that every country has a unique requirement needs with respect to energy. I mean, I'm sitting here and it's relatively cold, damp and rainy, and you're sitting there and it's lovely and warm and you're just worrying about the air conditioning. The wishes for our energy system, what we need it to provide, are absolutely unique to a particular country and its political situation.
Yes, you're very much right about each country having their own needs and requirements. And that very much is in line with how we need to address nuclear in Singapore, as it very much will be different to how it is in the UK. I would like to pass it now to Matthew, Head of Nuclear Strategies at HY, to continue on the conversation he started this morning.
Okay, thank you, Professor. Thank you, Sebastian. So a quick introduction for myself, for those that weren't here in the morning. I'm Matthew from a company, a Singaporean engineering consultancy called HY. And in a very short sentence, we are trying to be a smart energy ecosystem consultancy, which also includes talking about renewable energy integration, green energy integration. And of course, in the long run, this means nuclear as well, because that's a topic we feel very strongly that's going to be important. And so we decided to start this conversation now to talk about how to build these capabilities for the long term. And so I'm a nuclear engineer myself, graduated from MIT, and so that's a bit of my background. And thanks Sebastian for that introduction to myself. And so we talked about, and he's right, this morning we had a beginning session about nuclear, talking about opportunities in nuclear energy, how to create an ecosystem in Singapore, what are the considerations. And we felt that that was actually a very good starting point for this particular topic today. And it's very fortunate that we have a second session with Professor Grimes now. And it also gives us a unique opportunity to have a continued conversation from this morning. In particular, there was a question that came up about nuclear waste. And I think that's a very important point for consideration. As Prof. Grimes mentioned, when you talk about nuclear, every country has unique considerations. And in Singapore's case, of course, safety aside, because we have said that safety always is part of the conversation, one of the most common topics that have come up has always been, how can Singapore manage the nuclear waste component of it. And I think that was a very nice point brought up. And it's something that maybe we should use this session to continue the conversation, because I am certain in this whole room, if I were to do a poll, that would probably be the number one thing on your mind, or at least the number two. So we should talk about it. And I think moving into that, from that perspective, maybe Prof, can I just have some of your quick inputs on this topic about nuclear waste from your perspective in the UK? Like, what are some of the thoughts the UK citizens or even the UK government has on nuclear waste management?
Yeah, no, you're quite right. It is an absolutely key issue. And, a lot of the problems that the UK has with its historic nuclear fleet is that when those reactors were designed and built, nobody thought about the waste at all. And nobody thought about the decommissioning. They're not only turning off the reactor, which is a relatively straightforward engineering thing, but how you deal with the legacy of having that plant. And now any plant that's built has to have a plan from the beginning, including a financial plan. A levy is an example of a way of dealing with the financial issue. So there's an economic part of it as well as a practical engineering part of it. So turning quickly to the practical engineering part of it, I think one of the key things is to ask how much waste you've got. And remember that the waste comes in different sorts depending on how much radiation is associated with it. You have some that you can put in a specialist landfill because it is a relatively small amount, and that's the greatest volume. That's sort of 90%, 95% sometimes, depending on the reactor, of the volume. So to give you an idea, all the intermediate and high level waste are the ones that you need to worry about. The whole lot from all the reactors that have ever operated in the UK throughout our history fit into a geologic repository about the size of a large church, maybe a little cathedral, something like that, including all the barriers. So one of the things that's remarkable about nuclear energy is just how much energy you get from very small amounts of nuclear material, particularly nuclear fuel. I'm not trying to say that they aren't a challenge from an engineering point of view, but the volumes that we're dealing with are actually remarkably small.
No, that's very insightful, Professor. Linking to the first point that you mentioned about different countries having specific ways they have to tackle nuclear energy. Relating to the waste point of view, what specific challenges do you see Singapore having with nuclear waste?
So it's really about the spent fuel. I mean, there are other things, and one should never forget about them, but if we just focus on the most critical issue, it's the spent nuclear fuel. That's where the 99% of the radiation and 1% of the volume, remarkably, is based. So the question is, you take the fuel out of the reactor, and I can't imagine that Singapore would go down a reprocessing route, but there is a consolidation route. In other words, you take off the peripherals from the fuel bundles that you can take safely off, and you end up with spent nuclear fuel. Now, that spent nuclear fuel will have already spent probably a year or so in a pond with the initial radiation falling back to about a 10th or something like that. And then you have to understand how you keep that safe and secure for many thousands of years. Now, actually, we have a number of examples of where that has been carried out for decades. But the engineering challenge is to ensure that you have a way of keeping it for thousands of years, unless you can have a regional repository to put all this waste.
Thanks for that, Professor. Actually, when you were explaining about all this, talking about engineering barriers, thousands of years, I suddenly had flashbacks to my nuclear waste management class when I was doing my master's. All the exact words were being used. But I think one you brought up a very key point. Singapore can't do reprocessing. For those in the room to share, the reason is simple. It's a weapons proliferation concern. So Singapore can never do it. And so actually, I think the point that you raised about regional repository is something that has been brought up before in some conversations. Of course, it's one of those topics easier said than done.
Yes.
So, indeed, right? Exactly. But it's definitely something to think about. And so maybe just to probe your thoughts a bit on the comment on that, right? If we actually want to do an ASEAN repository, besides the geopolitical considerations that have to be part of the conversation, what are your thoughts on how ASEAN as a region could approach this concept, even just from a starting point of discussion?
Yes, absolutely. But first, going back to your geopolitical sort of comment, nuclear energy is one of those things that can almost never be divorced from the sort of geopolitical sort of framework that it's in, and this is just one example of that. So in terms of safely containing spent nuclear fuel, which is really what we're talking about here, there are numbers of different geologies that can be used. I think the world has come to the conclusion, and certainly there are now repositories being built with the idea that the spent nuclear fuel is put underground by something around 300, 400, 500 meters. So not massively deep, actually. I've been down mines much deeper than that. And that it's like a castle model often described. You have a moat, you have a wall, you have a keep, you have all sorts of barriers that if there's an issue with the first one, then there's another barrier which is even stronger for dealing with that, and then another one. So you have these engineering barriers. So for spent fuel, you would have it first of all in some sort of metal container. That metal container is then put into a clay surround, typically. I mean, there are other options, and that clay prevents water ingress in and out. That's then put in a managed geological position, which is then backfilled with material, and then finally there is the fact that it's 500 meters or 300 meters or whatever underground. So it's this sort of set of different engineering barriers which you will have thought about as well, I'm sure.
Thank you for that, Professor. And I think it comes aptly timed because I will be missing your lecture on nuclear waste tomorrow by being here.
You are, yes.
Professor, I
it's
hope
okay.
You for the class. You can give him
the
class. He's actually talking about it right now.
Well, yeah. Okay, all right. We'll see. But actually, you can link into that anyway, so it's okay. Don't worry, you won't miss it.
I want to move on now to another topic that Matthew discussed this morning, the topic of education, because
yes,
with nuclear and people who are looking to get into the nuclear industry, whether it be people like myself from the next generation or people in the private or public sector, it's important that people get the right education about nuclear energy. So I think just to start, I wanted to ask, what can the public side do to provide the education to various people who are looking to get into the industry?
Right. Okay. So there's a sort of the way we usually talk about these things is in terms of a triangle of skills. So you have a lot of people who are able to do the majority of the traditional engineering capabilities. The people who really know and are experienced in things like pouring concrete and getting the nuclear reinforcement of the concrete correct. You have people who understand how to commission pieces of kit that you need, for example, to run turbines and things like that. And you move up this pyramid, and maybe we should be talking about it the other way around, but who knows? But anyway, if we think about it that way for the time being, right at the top, you have your sector experts, the people who went to MIT and did nuclear engineering, for example, people who have done PhDs and who are real experts on particular types of projects. Of course, they're not very good at pouring concrete at all. So these different skill requirements must integrate in with each other as well in order that you have a robust set of people who understand the challenges and have the experience. In the UK, we have realised that there hasn't been sufficient numbers of new people being developed. So over the last 5 years or so, we've been thinking about various parts of this pyramid. Of course, we're building 2 large reactors currently, which are now in a very advanced stage. We will have another 2, which have just been announced. And then Rolls-Royce is going to produce a lot of smaller reactors. And I'm sure you're going to want to talk about that as well later. But each of those needs these particular sorts of skills. We've just announced that there will be 400 new PhD positions for nuclear, which will start from next October. There'll be about 100 or so a year with a drumbeat over 5 years. And that's the sort of thing that is required really for a large nuclear program. That's not going to be the case in every country. And I think this international collaboration on skills is going to be utterly crucial for all of us going forward.
Thanks for that, Professor. And actually, you actually highlighted a very important point about international collaboration, actually, to grow this capability. So, what are some of from your perspective, how can countries directly like Singapore actually collaborate with the UK to grow this capability over the long term? We obviously know that this journey for Singapore, even if we choose to go nuclear or not, is still a very long journey. So how would you, since you've advised UK government before, if you were to put you in a bit of this position, how would you advise Singapore from your perspective, or how we can proceed, just to get your thoughts?
Yeah, I mean, that's always a very, very dangerous question, indeed, because, sitting here a long way away and trying to understand the Singapore situation, of course, I'm not going to get it very right because I need to understand and appreciate the complexities that Singapore faces. But in general terms, and as I say, forgive me if I'm not quite accurate on this one. I think the key thing to start with is to ask, why does nuclear energy offer, or what does nuclear energy offer to Singapore? I mean, you're in an AI conference at the moment, and I actually spend quite a lot of time looking at AI agents with regard to nuclear. And one of the things that stands out for me is the staggering improvements in capabilities over the last 18 months that I've been studying this particularly strongly. It really is quite remarkable. And the things that you've been hearing about in your meeting, I think really bring that home to everyone. Associated with that, there is a very significant requirement for energy, both for processing, but also for collating and understanding data more generally. So you've got all the AI, really intensive energy takers, but you've also got the data issues. It's not going to be possible to engage fully in those sorts of activities within a border without very significant increases in energy as we have them. So clearly that's got to be at the heart of why Singapore is thinking about nuclear energy. So I'd say that's the first issue I would address. I think many countries can bring particular niche capabilities to bear on these sorts of issues. So I wouldn't. So if you think, for example, about Rolls-Royce has factories now in Singapore which make components for their engines, right? And I think very much there are opportunities to do very specialist, high quality engineering activities that Singapore is well known for. That is a possibility. So you then have this sort of interdependency between like-minded countries that help with each other's supply chains. So there's the sort of the opposite end of that sort of spectrum. But I'm sure your government is thinking very hard indeed about exactly how this fits in, and particularly how it fits into a longer term future. Many of the things I was when I was listening to the previous excellent speaker that you had, it struck me just how quickly things are changing again in the AI field. But what a long-term issue nuclear energy is, again, absolutely at opposite ends of the spectrum. It takes a very long time to set up and develop a nuclear engineering capability. And yet you are doing that because of very fast changes in things like AI. So that, I think, is a tremendous challenge.
Thank you very much, Prof. And also, I mean, I do agree. The question I asked can come across in, depending on how it's responded, can be tricky. But I think you've answered it in a manner that I have to admire, right? You've highlighted the key points that at least Singapore side can at least consider when engaging the conversation. Not because what Singapore should do, but at least what are the points that we need to consider as we begin down this journey, since we are still very early in this stage. So I do appreciate you being able to frame the question and providing that perspective, which I think is very useful for many of us, especially those in the room, as we also think about this journey for the first time.
Yes, definitely, and I agree with Matthew's point there. I wanted to touch on something that you briefly mentioned of how nuclear is such a long-term, involves such long-term projects, and a lot of the industry moves much slower than what AI is more used to. Used to with AI. As such, I think it's very much important that the next generation is engaged with nuclear now, and we get the talent built right now. And so I just wanted to ask, in terms of engaging the next generation, how do we engage people like myself and other Singaporeans? And also, how do we ensure that they are retained within the nuclear industry and don't go to other industries elsewhere?
Okay, so I mean, there are 2 points here in terms of education. There is the education of the experts that you need in that skills pyramid that we just talked about. But there is also the question of ensuring that people in Singapore understand what it is that nuclear is about, right? So this is one way of doing that is by offering courses at NUS and NTU, for example, in nuclear engineering, not so they become nuclear engineers, but so that they have an understanding of what those challenges are and how nuclear works in an integrated energy system, alongside renewables, alongside hydrogen capabilities, for example, if that ever happens, and conventional generation at the moment. So I think it's very important to offer people at those undergraduate levels opportunities to learn, and maybe even at high school as well. You know, part of the physics curriculum, for example, in A level. Understanding that mix, and Matthew will really understand this as a proper engineer, right, is understanding the integration issues from an engineering perspective is extraordinarily important, and I think traditionally is not necessarily something we've always done a very good job of in our education. So, and then of course the wider public as well, ensuring that people understand what is being thought about and why it's being thought about in this sort of way, so that people become comfortable or are able to help in the decision-making process. Possibly, I don't know. I mean, it's difficult to say. Now, in terms of the international, so actually, no. Before I do that, let me turn to this sort of issue of the time, because it's absolutely crucial. And nuclear projects have a reputation of being over time and over budget. Although I think the Korean story in UAE is a very strong counterexample to that. They delivered those reactors on time and on budget because they got the engineering right and thought about that right from the beginning. But speeding things up, how do you do that? And I think the small modular reactor story is one that's going to be very important over the next decade. This idea that you actually stop trying to build gigawatt-sized nuclear plant, and you come down to something about a third of the size of that. It has very important safety consequences, but actually, in terms of speeding things up, it's this idea that so many of the components can be made in a factory environment. They can be made, again, like aero engines, they can be made in a way that comes off a production line, so that we understand the issues, and the issues are the same for reactor after reactor after reactor. They're put on lorries, they're taken to the site, and they're put in. I mean, so much of engineering is like this. Why is nuclear not like this at the moment? Well, we hope it might be. And the other thing is the regulator then understands what these reactors are like, and as a consequence of that, again, the regulatory process is sped up. So I think this is going to be a really important part of the nuclear story in the next decade.
Thanks a lot, Professor Grimes, for that. I think what you've highlighted is very important points. Many people, even in the entire nuclear world, have been looking at, right, SMRs are meant to be more economical, meant to be faster, and also easier to license. I think the world is eagerly awaiting next year, if I remember correctly, right? The first land-based civilian SMR will go online in China, and so that will be the real, true first test of the SMR technology to see whether it really works as it's supposed to. And I think many of us are definitely looking forward to that. And so I would like to take the opportunity to actually open the floor to Q&A, because I am certain this is a topic that many folks actually do have questions they'd like to ask. And I would like to welcome questions from the floor to ask any clarifying questions about this entire field, because as you can see from this conversation, guys, the nuclear topic covers many, many, many aspects. So I'd like to take the time. Any questions from the audience that would like to take a chance? Yeah, gentleman in the front.
Hi, I'm Louis. I'm just curious because the tragic circumstances of Fukushima, right, impacted a land area in the radius about 30 kilometers. I did a bit of a calculation that works out to be about 2,800 square kilometers. And Singapore, of course, is about 700 to 800 square kilometers. That's about, well within the radius of the potential fallout of an old modular nuclear reactor. I'm not sure how a fallout for a SMR is going to be like in the event if it does happen. But my question really is, what do you think would be the impact on the quantification and the value of land prices and properties in Singapore in the event if there's an unlikely event of a meltdown in SMR? I think that's probably more important questions to us. Thank you.
Yes, absolutely.
Very Singaporean question, I would have to agree. Professor, would you like to take it?
Yeah. Oh, no. I think you put your finger right on the key question there, indeed. There has to be absolute certainty that any plant that generates energy within the borders of Singapore is so ensured in terms of that issue that it simply gets taken off the table. I mean, there are, in fact, engineering solutions to that. The question is would people accept and actually have faith in that engineering solution? And those are two different things. I mean, I'm sure Sebastian and Matthew would agree with me from an engineering point of view. We know how to do that. Of course, there are price implications with respect to that, because you have to build in additional certainty into your engineering systems. But that doesn't make any difference if the public is not content with the solution that's been offered. So from an engineering point of view, you would possibly build, you have fabulous capabilities of building caverns to put some really quite remarkable things down them. And I think it would be the case here, is that you would probably although not definitely, but you would probably go underground. I mean, there are other options such as floating reactors as well that can be moved out once they come to the end of their lifetimes. That's actually so this isn't the only one, but an underground repository for the reactor and the spent fuel as well is absolutely within engineering capabilities. But will people accept that to be the case? And because there cannot be a release of material in Singapore, that's very clear. I don't know what Matthew and Sebastian think about this.
No, I think, Prof, you summed it up quite nicely for the considerations as well, and answered the point. Absolutely, I can agree. Many Singaporeans do think about potential fallout and how it affects the country, given the fact that we are, for all purposes, a dot on the map. So I think it's a very valid question that has been brought up. Sebastian, anything to add?
Sorry, Ruff. Go ahead. Go ahead.
No, you first.
I was just saying, I agree with what Matthew and you have said about is definitely a thought that everyone has about nuclear, all of the fallout, the waste, and it's very much important that yes, the engineering side does work, but how do we win the hearts and minds of people and allow nuclear to people to accept nuclear in Singapore as well. So I hope that answers your question there.
Can I just make one slight additional point on this as well? I mean, one of the things that we teach in our master's nuclear engineering course is nuclear accidents and why those nuclear accidents occur. And there is one thing that is common to all nuclear accidents that have ever happened right back to the 1950s, and that is people. It's decisions made by people that led to those accidents. And I was on I worked with the Japanese government and the British government during Fukushima very, very much. In fact, that's in many ways where I first started working specifically for the UK government. And actually, there are numbers of myths around the Fukushima issues, and there was a tremendous amount learnt from that. And we don't have enough time to go into it all today. But it all came down to people and the way that people interacted with the engineering system. And I was struck, when you think, how can AI and nuclear, what's the commonality? Well, we can talk about systems engineering commonalities, but the other commonality is it's about people still.
Thanks a lot for that, Prof. Yes, there's more questions. All right, please.
Yeah, thanks a lot, Gabriel here. I think I know some of you. So, okay, so in terms of the hurdles, right, this is Chapman rules, the real adoption for nuclear energy. So the risk of the fallout, the caverns, the engineering, the people, right? What else is missing in terms of hurdles? Costs, okay, that might probably go down. Anything else? Is there something that we're not talking about that is going to switch that thing from us adopting nuclear energy? Because these 5 or 6 items, if it's a timing to win the hearts of men, then the facts and the pragmatism will take its course. But is there something that we have not spoken about? We take aside political will, we take aside geographically, there's a way to do it, but what else we have not spoken about? Yeah.
Thanks for a great question. Prof, I will
that is a good
first, and then maybe we can comment further. I think the answer to your question and also the consideration is one key point: a proper workforce in any country, right? We talk anything that Prof mentioned, the risk of fallout, the safety systems, all that cannot be managed if you don't have a fundamentally rooted workforce within that country. And I don't mean a workforce that you can just outsource and bring them to Singapore. It needs to be a workforce unique to that country or that geography, right? As Prof pointed out in one of the questions I asked, right? He said, I'm not in Singapore, so I can't give you the specific answer to the question. It's going to be the same with any workforce. You bring someone overseas, yes, they will do the job, but they will never understand the unique constraints of that country. And so that is the key thing that will benefit all the points that were raised up to that point, up to your question. And so that's just my input on that. Prof. Sebastian?
Yeah, I completely agree. And actually, the idea of bringing all your workforce in from abroad is that, of course, they then leave at the end of it. And you need people who have, I think the Americans would say, have skin in the game, right? That it's their country that we're talking about, and so it matters to them and their families. That is a very powerful narrative, I think, for any country. So yes, absolutely, you need experts who are able to help make the salient decisions, who understand the local concepts and environments. Now, again, returning to that fundamental question of how does Singapore see itself engaging in an energy-intensive world of data, AI, and actually high-end manufacturing as well? Where's Singapore going to get its energy from? And your population is significant for your land area. So you don't have a lot of area for solar. You don't actually have very much wind because of where you are. So you have difficult decisions. So I think it also comes back to the geopolitical. And I think perhaps those discussions as well, and in trying to help and guide and cooperate in really good engineering environments with neighbours, is perhaps a difficult and way above my pay grade conversation that has to take place as well. Now, actually, you do have a nuclear department at the National University, and I know that Nanyang Technological University also has a group of people looking at fusion energy capabilities as well. And both of those have international support associated with them. So Singapore is doing some things here to try and ensure that it has excellent people in these areas moving forward.
Okay, thanks. I think I just made a small one, probably that conversion of current engineers that is on our power plants. I know it's not that simple, yeah, I get it, but that to convert to be able to cover that 70%, right? And then the 30%, we have to hire and build from scratch. Anyway, that's the point. Thanks.
Thank you very much.
Actually, you've just made I think you've made a very, very important point at all. Indeed, and that is that in these energy systems, most of the people you need are not nuclear people. They are people who understand how to put together power engineering requirements, people who understand turbines, people who understand the movement of energy and heat around a system, people who understand the civil engineering with a nuclear capability, but nevertheless who understand the civil engineerings, the designs, etc., etc. So yes, the number of people who really have a nuclear engineering hat on that you require is relatively small.
Okay, just a fun fact for everybody before I go to the next question. To the point that Prof just raised, in a typical conventional nuclear reactor, you have maybe about 1,000, 1,005 workers, of which only maybe 5% are nuclear engineers. The rest are common engineering, welders, technicians, you name it. Fun fact. I think that's a question. Right?
Welding, absolutely. Being able to do really good welding, very underrated.
Firstly, thank you to the experts for a very interesting session. I have a quick question. I am curious because Singapore is such a significant port in the region. Do you see any opportunities to integrate nuclear energy in the maritime industry?
That's a very good question.
We were actually just talking about this last week, I think, briefly. So, Prof, do you want to share what we discussed slightly?
Sure. Yeah. So, first of all, nuclear and maritime has, of course, been integrated for a very, very long time. Numbers of countries have nuclear submarines, and those are very significant power plants in those nuclear submarines. And there's, of course, regionally the UK, US, Australian program AUKUS is starting up. So there'll be a new nation more closer to you with nuclear capability. The Americans, of course, have always put nuclear reactors in their aircraft carriers. They have generally 4 reactors in their very large carriers. The Russians have had exactly the same capability, and in their icebreakers as well. They have nuclear icebreakers as well, although perhaps their ability to deal with the waste and spent plant afterwards needs thinking about a little bit more. So the answer is, we know that can be done. We know that that is an issue, quite an important part of CO2 emissions from maritime. So there's a big push in this regard, and numbers of countries are thinking about this at the moment. They're thinking about it from the point of view of the engineering requirements and capabilities. I mean, countries like Norway, for example, are strongly thinking about that as well. So Norway has only ever had one little test reactor, really great reactor, but one little test reactor in its history, which is stopped. So that's a new entry in this regard. So the concerns have generally been, I mean, if you've got a reactor on something like a submarine or on an aircraft carrier, then you've got built-in security. The question is, what does security look like in a marine nuclear context, particularly when you consider that some of the sort of ships get attacked by pirates and things like that. So, you know, again, I've covered quite a lot of different issues in here, but I think we'll see a lot more interest, a lot more talking about that issue. So, good one.
Thanks a lot, Prof. Actually, yeah, I think you have time for one last question, please. Yeah.
Hi, sorry, I have a question, or 2 questions, sorry, if I may. So I'm a pretty firm believer in nuclear deployment in Singapore because I believe it is the only viable solution that solves the energy trilemma of cost, security, and low carbon emissions. So actually I would like to ask, as you pointed out, public perception is a pretty important problem to solve before it can be deployed. What would be, for each of you, what would be one thing that you wish the public knew or understood about nuclear? For example, it could be the fact that the evacuation at Fukushima actually caused more damage than the fallout itself, or the fact that there's passive safety in Gen 4 reactor designs. Those are some examples. And my second question would be, if you had $1 billion each today, where would you invest that? Would it be like, for example, small modular reactors like HTGRs, or would it be reprocessing, or would it be fusion? Yeah, for example. So, thank you.
Perhaps I'll just go a quick answer on both of those points. Firstly, if I had $1 billion, I'll probably retire right now. That's what I would do. No, but jokes aside, I probably would invest in building the ecosystem within Singapore, getting the right companies in the right parts of the value chain, so we can build the ecosystem within Singapore to prepare ourselves for an eventual nuclear future or even a regional nuclear future, just to get it ready. And if to your first question about what I think the public should be aware of, I would just say it's just a general understanding about the nuclear field in general, enough that they can at least do their own research, right? Instead of being influenced by echo chambers where they may be providing fake news or even worse, misinformation. So I think that's a very key thing I would like the public to have, just that basic understanding so that they can do their own research.
I think for me, I would just answer it quickly and give the rest of the time to Professor. For me, I think the one thing that I wish more people would know is the difference between nuclear in a defense context and the difference and nuclear in a civil context. Because things like the fuel, The reactor types are very much different, and a lot of the public doesn't know the difference between the two of them. So they generalize the whole industry, and that gives the bad PR side quite a lot of bad PR. So that's one of the aspects that I wish more people knew the difference between the two of them. In terms of if I had $1 billion, I would probably drop out and start a startup right away. But in terms of, sorry, Professor, it's just a joke.
Good.
I got one more year left. I'll just write it out anyway. But I think I would invest in various parts of the value chain and also cultivating the workforce in Singapore, getting people invested and interested into nuclear in Singapore. Now, just for the remaining time, Prof, would you like to answer the question as well?
Yeah. I'll do it in two parts. First of all, I couldn't agree more, Sebastian, and Matthew made the same point. Look, you need to ensure that people know sufficiently to come to their own conclusions. Telling people that nuclear is a good idea, it can actually be massively counterproductive. Explaining the issues so that people can come to a decision as to whether or not, I think is absolutely a much better way of doing it, and something, by the way, it took the UK a long time to realise. You asked specifically about reactor types, and if I was a betting man, and I am absolutely not, I've never even bought a lottery ticket. I know the odds too well. But if I was, I would put it into high temperature gas cooled reactors, as you just mentioned. And the question is why? So I actually think from a world perspective, the future is actually in something called cogeneration. So this is the idea that you have sufficient baseload capacity provided by your nuclear reactor fleet, along with other generating capacities in an integrated manner, that there are times when you have excess energy that you can use to do other things that also decarbonize your overall energy system. So this might be simple things like desalination and district heating, which you can do with conventional PWR type reactors. But there are an awful lot of industrial processes, particularly chemical engineering processes, where you need higher temperature process heat. And the high temperature gas cooled reactor, and the clue's in the name, provides you with those higher temperature outputs that you can use to decarbonize difficult industrial processes. And I think the future of nuclear actually will be in this idea of nuclear cogeneration. And for me, the reactor that has been shown to be incredibly robust, I mean, the German Dragon reactor, at the end of its process, they actually gave it a very carefully designed accident scenario where they allowed the fuel temperatures to increase in a situation as where you had, they hadn't lost control, but they made it look like they were in that process. And the temperature of the fuel did exactly what it was expected to do and maintained its integrity entirely and came to a steady state. So I think that was a very important demonstration of the robustness of that reactor system. And it is a high, as I said, it's high temperature, so cogeneration. So that's, I guess, where I would put my £1 billion. It takes more than $1 billion probably to get all that sorted out. But that's what I would do. And indeed, my own personal research group activities is based around those sorts of ideas with international collaborators across the world. We are very much, I mean, research is very much like that anyway, and nuclear research in particular. So there you go.
Thank you so much, Professor. I think we've just run out of time, so thank you so much for your time today, and thank you all for listening to us today. If you guys have any more questions, feel free to approach me or Matthew later. And yes, thank you so much again.
Thank you, everyone.
Okay,
Thanks,
Thank you.
Professor.
you're welcome.